So we just discussed the unit vector, the magnitude of the unit vector. We found that with the examples it was 1, and now we discussed the magnitude of a normal vectors when we add up two vectors, and now we discuss right now the direction of a resultant vector. So we already talked about the individual vectors. Now we are talking about so we already discussed the addition of the vector, and now we try to find or discuss with the examples the direction of the resultant vector. So direction of the resultant. So in the previous lectures we talked about the direction that we can determine the direction by the angle, that how far is it from, for example, we have a vector, so this is the angle that's making it's making with the positive x-axis. So that's important. The angle is always we take with the positive x-axis, right? How far this vector is from the positive x-axis. So this is the positive x direction, and so we have the theta. So here in this case, so if we know that how far this vector, so this is the, right now we talk about only the resultant vector. So if we know that how far this vector is from the resultant or from the positive x-axis, then we know what is the direction of the vector. So we have the formula for that we already derived in our previous lecture. So this is the y divided by x. So for that we need the y component of the vector, and then we need the x component of the vector. So what we need is this one here is the rx, and we need the ry. So, and the second thing that we need is the identify the quadrant. So what does that mean? So here right now, so we have the 4 quadrants as we know. So we have here the x-axis, and we have the, so x direction, we have, this is the minus x, so this is y, and this is minus y. So if the angle is here, so it will have the positive x and positive y. But if the vector is here, is located in this direction, then the x component is negative and the y component is positive. So similarly, so if we have the vector here, then the both x and the y components are negative. So if the vector is here, so we have the x component is positive and the y component is 0. So that's important because as we said that the angle, we always take it with respect to the positive x-axis. So for that, if for example the vector is here, so the angle is making with this one. So what we do, we first find out this angle, and then we subtract this from 180. And so if we subtract it from 180, because the whole thing is the 180 degrees, so the line of the whole line is 180 degrees, so we will get this angle here. So we will discuss this in, right now we are discussing these things here. So for that we need the Rx sine plus Ry sine, the sine of Rx and the sine of Ry. So from these two we can get the idea in which quadrant this vector is lying. So we have the first quadrant. So for the first quadrant, as we see, the our x is equal to positive. So for the first quadrant, we can see that the our x is positive, has a positive sign, and the ry has a positive sign. So the same thing, that tangent of theta, or we can just write the theta is equal to the tangent inverse, and then if we know the ry plus rx divided by rx. So this is then, if we have this information, so then we can find out the angle. So we have the example. So r equals 3i plus j. So this is the resultant vector. So the resultant vector is given, and we are asked that what is the angle between, what is the angle with respect to positive axis. So for that, so we will try three different angles. So we have the tangent of 30 is equal to 1 by 3 under the root, and tangent of 45 degrees is equal to 1, and tangent of 60 is under the root. So we will try these three different angles. So the theta here is tangent inverse. So we have the under the root. So what we just see here, so this is the 30 degrees. So the theta is equal to 30 degrees. So if you remember this value of the degrees, the final degrees, so these 3 degrees are important. They are usually asked in the exams. So similarly, if the r given the second example, so example number 2, if we have the I plus j, so if they are equal, what is the angle? So the angle is tangent inverse 1 by 1, because the magnitude here is 1, the magnitude here is 1. So we can see here, so this tangent is 1, so the angle is 45 degrees. Now example number 3. So if r is equal to I plus 3j, so the theta, so we want to know the theta. So tangent inverse, so here we have the ry here, this is the ry divided by 1. So this is so we just compare it here, so we get that it's the 60, the angle is 60 degrees. So you just need to remember these values, and then you can easily find out what is the angle between the resultant vector and the positive x-axis. So this was easy because the vector itself So this is the positive axis here. So it was easy because it was in the first quadrant, so it was easy. The angle here, this angle that we got was the angle that was required. But in the second quadrant and the other quadrant, it is important because it's a little bit different, because we will get this angle and then we will have to do a calculation to get it with respect to the positive x-axis. So right now we will discuss the second quadrant here. So for the second quadrant means that R is equal to minus Rx I plus Ry plus j. So the x value is negative and the y value is positive, because here, so this is x, this is y, so this is minus x, this is y, this is minus y. So our vector here is here. So right now we will find out what is the, so this is r, so this is our ry, or we can also take it here, so this is also ry, so this is our rx, and this will be our phi, and this is our theta. So we will find out what is the value of phi, and then we will calculate the value of theta. So we can see here, so the value of theta plus phi is equal to 180 degrees. So value of the phi plus the theta, so it's a straight line, so this is angle is 180 degrees. To get this theta, what we have to do, we have to subtract the phi from 180 degrees in order to get the theta. So we will first get the theta, so the phi. So we will calculate what is what the phi is when we get the phi using this method here, and then we can calculate the theta. In this case, the theta and the phi was the same, but here they are different. So example is, so this is the example. So if you are asked in an exam, so we have the 3 under the root I and plus 1j. So we want to know what is the value of the theta. So we get the tangent inverse is 1 by, so we always take the positive value, or when we want to do this these calculations, we just ignore the sign here. So this is what we see here is 30 degrees. So this is 30 degrees. So the angle is 30. So now we have the phi, so this is phi. So this is phi. So the theta, as we saw, is the 180 degrees minus 30 degrees, which is equal to 150 degrees. tangent 30 is equal to 1 by 3 tangent of 45 is equal to 1 and tangent of 60 degrees is equal to 3. So now we take another example. So this is the example. So when the R, the resultant vector here that is given is minus I, so it's again in the second quadrant, plus J. And we are asked that what is the angle between these two. So just to draw it here again, so this is the phi, and we want to know what is this angle, which is theta. So this is the resultant vector here. So we know that phi is equal to tangent inverse. So here is minus 1, so we take 1 by 1, as we said that we ignore here the sign and we just take the magnitude here. And we know this tangent is here is 1, so we just compare it here. So this is the phi is 45 degrees, but we are interested in theta because we said that the direction is always represented by the angle with respect to the positive x-axis. So the theta is equal to 180 degrees minus 45 here, so this is 135 degrees. So another example, when the R is minus I plus under the root 3j, and we are asked to find out what is the angle, so this angle here. So here we can just simply see from these values that theta is equal to 45, so the theta is, sorry, it's 60 degrees if we subtract it from 180, so the phi, this is phi and this is theta, and this is 120 degrees, so this is the theta. So this is how, so if you remember these values here, you can easily find out what is the angle between the resultant vector and the positive x-axis. Now we talk about the third quadrant. If we have the vector in the third quadrant, so the value of x, our x is negative, I in the x direction, minus our y is also negative. So it means that, so we take the, just draw, so here is the positive x, we have the negative x, we have the positive y, and we have the negative y. So our resultant here, so this is the resultant. So this is the resultant vector, and when we split this into ry, so this is our ry, and this one here is our rx. So here the angle, so this is the phi here in this case. So we will find out what is this value of the phi using these components, perpendicular components, but since we are interested in this angle, which is theta, so what we have to do, we can see here, so this angle here, the straight line, so this is 180. If you want to find the vector, the angle between the vector and the positive axis, we have to add it with the 180. So the theta here is 180 degrees plus phi. So it's different from the other. So it's easy. So now we have the formulas for that. So if we know what is the phi, so we can easily get the theta. So we get the example. Example is R equals minus j. So this is I, and we want to know what is the value of theta. So this theta here, not this one. So we will first get the phi. If we compare it with the values here, so we have the tangent inverse. So we have the 1 by under the root 3. So we get there, so we get here the angle is 30 degrees. So if we add this with the 100, we were interested, so this is the phi, sorry, this is the phi. So this is the phi, so we were interested in theta, so it's 180 plus 30, so the phi is 220 degrees. Now we have the other example. It's minus 3i minus 3j. So if we put the values, we will get the tangent minus inverse is 1. So if we compare it with those values, so we will get that the phi here is 45 degrees, and theta, if you add it to the 180 degrees, so we will get the, so it's plus 45 degrees. So this is how, so in the third quadrant, this is how we get the values here. So here we see, here we got the value of phi, and we just simply add it to 180 degrees. So this is how we get the angle, the theta in the third quadrant. So now we discuss the fourth quadrant here. Quadrant. So in the fourth quadrant here, so if we just look at the, here we have the x, we have the minus x, we have the plus y, and we have the minus y. So here, this is our R here. So what we get, so this is our R. If we split this into perpendicular components, so this is our Ry. So this is minus, and here is our x, which is positive, and this is the phi. So if we solve this problem, if we want to know what's the angle or the direction of this vector, so we will get this angle, which is phi. But as we said that for the direction, we always use the angle with respect to the positive axis in the anti-clockwise direction. So this is theta. So here, what we see here, so this is almost a complete circle, but minus this minus this phi. So the angle of the complete circle is 360 degrees. But since we are interested in this part, so if we subtract the phi from the 360 degrees, we will get this angle. So the resultant vector will be Rx plus Rx, so this is plus here, and minus Rij. And the angle, since we know that theta plus phi equals 360 degrees, because the full circle is the 360 degrees, but we are interested in theta, so it will be 360 minus phi. So example, we have the r that is given is I unit vector minus 300 under the root 3 j. So with these values, we can already guess the value of the vectors. If we put these values in this formula, so we will get that the angle here is 60 degrees. So the phi is 60 degrees and the theta is 360 degrees minus 60, so it's 300 degrees.